So in the previous lecture, in the previous video, I explained you can carry out the hypothesis testing in the same way as you learned in chapter 9, right? And actually I should have shown you this slide at the end of the previous video. I forgot. So from this result, can you reject the null hypothesis or not at 1%? So you may use t-statistic approach, or you may use p-value approach, or you may use critical value approach if you want, right? So pause the video and try, and when you're done, I'll give you the answer. So if you take the p-value approach, this p-value tells you the resulting p-value from this null hypothesis. So p-value is 0.0%. So at 1%, you should reject the null hypothesis. That is the p-value approach. Second, t-statistic approach. This t-statistic is based on this null hypothesis again. So this t-statistic is 11, greater than 11. Remember, t-statistic, if the t-statistic is outside plus minus z alpha over 2, you have to reject. So if the t-statistic is too large, that means the difference is too large. Standardized difference is too large. And how large is that? How large is too large? That is z alpha over 2, which is 1.64 or 1.96 or 2.56. No matter what you choose, 11 is too large, right? 11 is anyhow too large. So you are going to reject the null hypothesis again in the t-statistic. And if you use the critical value approach, then you first have to find z alpha over 2 and then multiply the standard error. And that is the margin of error around your null hypothesis. And if you do calculate, then this coefficient will be outside of that margin of error. So you will reject the null hypothesis again. So the simplest way is to take this p-value, compare the p-value with the significance level, then you don't need to calculate anything. The answer is yes. And this is important. I said the reason why we consider this specific null hypothesis is because traditionally it has been important, right? The hypothesis imply when beta 1 equals to 0, it means that the variable x has no effect on y, which means your model is nothing. So the purpose of our regression model is to explain y using x. But if x does not have any effect on y, then you cannot explain y using x. Then there is no point of doing this regression analysis. That is why this hypothesis is usually the first hypothesis we consider, right? And in this case, rejection is a good news. You rejected this null hypothesis, so now your regression model has some meaning, right? So now it means that x can explain y. X explains y statistically to some extent, right? So rejection is a good news, right? And then again, the p-value is smaller than alpha, then you reject the null hypothesis, so your regression model is meaningful, your variable is meaningful, which is good. So this is called statistical significance. Like beta 1, we usually say that the coefficient is statistically significant, or the estimator is significant, or the variable is significant, no matter what. Statistical significance is a common way to describe the rejection. Then let me explain the history first. Actually, regression, the history of regression is more than several like hundred years. So the regression model has been used like in the old days. However, the hypothesis testing, the estimation theory you learned in chapter 8, 9, 10 have been developed more recently, like within like 20th century. So that's why the terms are not consistent with each other. That's the problem. So for example, the term statistical significance has been used like a much long before hypothesis testing was developed. Later, statisticians find that statistical significance can be understood as the rejection of this null hypothesis. So the terminology is not clean. So different people use different names and different have different motivations, but in the end, they are equivalent, something like that. So anyhow, but by the way, statistical significance is really important term, and it's like quite often used in many like in practice, right? So remember this term. And now I'm going to show you another example, a real example, in the next video. I did not prepare the data set yet, so I have to download the data. So I'm going to demonstrate a real data set and regression analysis on Excel. See you in the next video.